For retiree healthcare coverage for life age 60 with 30 years of service at the valuation date, we're given the healthcare benefit premium at age 65 is $3,000. There's inflation 4%. Premium increases by 3%. We can use the standard ultimate life table. Retirements occur only at age 65. Annuity due is 30.5. We assume linear accrual for the healthcare benefit with 5%. So we want to calculate the normal contribution for this life at the valuation date. One thing to note is the formula for the normal contribution for linear accrual is 1 over T plus K times AVTHB sub T plus expected present value of mid-year benefits. In our case, there is no mid-year benefits, so we're going to cancel that out. T is the number of years of service, and then K is the number of years until retirement. Okay, so in this case we have 30 years of service, and currently the person is age 60, retirement is age 65, so that's an extra 5 years. So then we want to multiply that by AVTHB sub 30. So in other words, the normal contribution when T is 30 is AVTHB sub 30 over 35. So now let's look at a time diagram. Okay, right now, person is age 60. We're looking at age 65, 66, 67. So they're going to retire at age 65. So we're going to keep that as our starting point. And there's going to be a benefit 65, and that is 5. T is 5 here, okay, because that's all based off how many years since 60. Okay, so that's 5 years. And currently we're looking at age 65. Okay, so age 65, we have a premium as this. So the age and then the time. Okay, the next year we're going to increase the age by 1 and then increase the time by 1 as well. Okay. So next year it's 66, 6, and then we're going to discount it back to age 65. And then the next year it's going to be 67 for the age and time 7. Discounting it back 2 years. When we're discounting it, we also need to include the probability of survival. So for here we need to have P65, and this will be 2P65, and so on. Okay, well, I can factor out B65, 5, because what's the difference between going from, let's say, B65, 5 to B66, 6? Well, the benefit premium is going to increase due to inflation and due to age. So I think the inflation we said is 4%, and the age increase is 3%. So together, that's 1.03 times 1.04, which is 1.0712. Okay. So every time it's going to increase by this amount. So we have 1 plus 1.0712 VP65 plus 1.0712 squared v squared 2p65, and so on. What this becomes is just the annuity due. And now the B65.5, well, that's the premium, the benefit premium at age 65 times 0 multiplied by the inflation factor. Okay, so it's 5 years, so it's going to be 5 years of inflation. Okay, multiplying that by the annuity due. Okay. But this was all based off age 65. So to go to age 60, we need to discount it back 5 years. So that would be surviving 5 years, starting at age 60. So this is the AVTHB sub 30. And we have all these values. Okay, so v to the fifth, p, actually v to the fifth is the interest rate, discounting it back 5 years. Survival, we can get that from the Standard Ultimate Life table. B65 times 0, the premium there is 3,000, and this is 30.5. Yeah, so when we do these, we get 0.76687 times 3,000 times 1.04 to the fifth times 30.5, and we get that it's 85,370.84. So now to get the normal contribution, we're going to take that number and divide it by 35. And so the final answer is 2,439.